Question 13, it says, given that x and y are integers, that's whole numbers, such that x is between 3 and 7, y is between 4 and 9, and x plus y is 13. So let's have a look at this first one here. Now, that means x would lie between, and I'll just enlarge this a little bit. This would mean that x would lie between 3 and 7, but cannot be 3 and cannot be 7. If you wanted it to be 3 and 7 also, then that's what you'd write. Okay, but that's not what we had here. So we know to start with that x could be the following numbers: 4, 5 and 6. Y, on the other hand, lies between 4 and 9. Can't be 4, can't be 9, but it could be 5, 6, 7 and 8. And then the last thing that has to be satisfied here is x plus y equals 13. So let's add x and y together and see if we get 13. Well, if we try 4, add any of those values of y, at most will be 12, so we can't get 13 there. So this one, I'm afraid, is out. We could do 5, add the 8, that would work. So it looks like x could be 5. And also, if we do, and I'll do another colour here, we could do 6 and the 7, that would make 13. So it looks like the values of x that are allowed will be 5 and 6. So let's have a look at the next part. Well, here we have 3 inequalities that need satisfying, and once we've satisfied those, we should be able to find a region which we can label with a capital R. Now, the way that I usually do these is to treat them as if they were just equalities, i.e. equal signs to start with. So I'll have y equals -1, that's this one. And where is y equal to -1? Well, I don't have a ruler here, so I'm just going to do it freehand. So my first line would be here, going all the way across. And I'll label that y equals -1. Then I'm going to look at this line here, and I'm going to treat that as y equals 4 minus x. In fact, better still, let's call it minus x plus 4, which is just the same. And hopefully, if you can remember your straight lines, if we had y equals minus x plus 4, then 4 would be the intercept, and minus 1 would be the gradient, because we have negative x, so minus 1x. So the gradient would be -1, which would mean every one I go along, I just go down 1. Go along 1, down 1. In fact, go along 3 here, and I just go down as much, 3. I only need 2 points to plot a straight line, so I'm going to give it a try here. In fact, I'll pause the video and probably do it better while I'm not recording. So that's that one, and we'll call that y equals 4 minus x. And then we've got this one here, and that we'll call y equals 3x minus 1. So here we'll have an intercept of -1 and a gradient of 3. So if that means I go along 1, I would go up 1, 2, 3. I only need those 2 points, that should be enough. So if I go along another 1 and go up 3 more, that'll be enough to help me plot my straight line. Okay, not too bad. So y equals 3x minus 1. So let's try and look at doing these inequalities now. So we've got to satisfy the inequalities. So this first one, y has got to be greater than or equal to -1. So if I choose another colour here, say blue, then if we shade in everything which is more than -1, and equal to, that will just be the purple line anyway. So that's the first one done. The second one, we want everything less than or equal to the line. So we want to go less than the line 4 minus x. So I'll hold my pen at a different angle here and shade that. And then last but not least, we want y is less than or equal to 3x minus 1. So let's shade this part in. Now, what we're looking at here is shading that has been shaded 3 times. So hopefully you can see the regions that it can't be first. So it's not going to be in here, that's just once. Here, well, that's twice, so it's not going to be in there either. This part, that's just twice. This part, twice. But can you see here, we've got lines going this way, lines going down, and also lines going across. So it's this region here that we're interested in. So first of all, we're going to put our capital R in there as our region. And we're going to make sure that it can be all the bit on the outside as well. In fact, I'll make the pen a bit thicker here. So it can be this part here. It can be this part here. And it can be this part here because it's equal to. If it was just greater than or just less than, then you would have to do dotted parts on the outside. Okay, so I hope that's explained reasonably well enough, but that'll be the answer for that question anyway. So question 14, we have question based on percentages, and we've got to be very careful with this type of question. They can be quite tricky. So let's write down 2014 and 2015, and then it says in 2015 patients waited 11% less time than in 2014. So if we say 2014 represented 100%, then we're saying that in 2015 11% less time, so we'd have that representing 89% compared to the 2014. But it says in 2015 the average time patients waited was 68 minutes. So it's like saying that 89% represents 68 minutes of waiting time on average. So to do some workings, we can do that here. So if 89% represents 68 minutes, then we've got to try and work out what the 100% would be. Okay, because it says work out the average time patients waited in 2014. So you've got a calculator, and by far the easiest way of doing this is to make this 1%. And the way of doing this at this particular level is not by taking 88 and making it 1. It's always multiplicative or divisional. So it's either times or divide. And we want to make the left-hand side, i.e. the 89%, 89 times smaller to get to 1%. And then we must do the same to the minutes involved. So we must do 68 divided by 89. And I'm not going to do anything on my calculator just yet. So 1% represents 68/89ths of a minute. Okay, so I can write that there. And then all I want to do is get back to 100%. So I won't be adding 99, I'll be definitely timesing by 100. So I'll be going from here to here by timesing by 100. So I've got to do the same to this. So I'll have 68/89ths times by 100 minutes. And I'm sure that's easy enough to do on your calculator. You can either do 68 divided by 89 times 100 or 68 times 100 divided by 89. So let's see what we get. So I'm going to do 68 times 100 divided by 89, and I get 76.40449 and so on, and it wants it to the nearest minute, so it's going to be clearly 76 minutes to the nearest minute. So I just want to recap on the steps that I did. I divided this by 89, and I had to do the same here proportionally to get to the magical 1%. If you can always get to 1%, then you're most of the way there on questions like this, and then times by 100 to get to what 100% would be. Okay, so just keep that in mind. So let's look at part B now. Well, first of all, we can write down 2015 and also 2016, and it wants to reduce its time from 68 minutes to 60 minutes in 2016, and you've got to work out the percentage decrease here. Well, these aren't too bad. Always remember where you start from. And so if you want to look at the percentage change, you're always comparing it to where you start from. So what's the difference in time? 8 minutes. What are we comparing it to? Well, where we started from, which is 68. And basically, we've just got to make 8 68ths as a fraction into a percentage. That's all we have to do. So can you remember how to change a fraction into a percentage? Well, if you think about the fraction a half, how do you change that into a percentage? You know it's 50%. Well, you just times by 100%. And a half of 100 gives you the 50. How do you change 3/4 into a percentage? Well, you just times it by 100, put a percent sign there, and you've got your 75% that you want. Okay, other people prefer to decimalize this. So if we were to decimalize, we would have 8 divided by 68, which would be this. I'll write it all out. And they would then make sure that to be a percentage, so it's like having probability where you can have decimals this time. So to change a decimal into a percentage, well, most people I think here would be fine with realizing that would be 11.764 and so on. So in this case, we want to put down, and it wants it to, I think, I'm just trying to see how many decimal places it wants it to. It doesn't say, so I'm going to write it to maybe 1 decimal place, and let's have a look. So we'd have 11.8% to 1 decimal place. I'll just write that here. So just to recap quickly, you can either do 8 divided by 68 or 8 68ths times 100% straight off, and you'd get 11.8 to 1 decimal place percent, or you can decimalize this first, have a good look at it, and then work out what you think the percentage should be by just looking at the decimal. Okay, so that's that question sorted now. So question 15, the first thing we have to do with this question is to explain, so it's QWC here, explain why angle BCD is 90 degrees. Well, without going into too much explanation here, if we have a diameter, which is shown here, BD, then angles in a semicircle are always 90. So this one would be 90 here. If I went from here and then back to D again, that would also be 90. There's another one there. Okay, and you could keep going. And that's also a spin-off of the other circle theorem, which says angles in the same segment are equal. So they're all in a semicircle and they're in the same segment and they're all the same and they happen to just be 90. So what we write for the explanation is we would just write angles in a semicircle are 90 degrees. Okay, that's all you have to write, and this is a shorthand for angles. The next part of the question wants you to calculate the length of BC. So this length just here. So let's have a closer look at the diagram. Now, if we just call BC, say, Y, and label that, we know this is a right angle, okay, from the first part of the question. Okay, so that's a right angle. We also know that this is a radius here, from here to here. And the key, I think, to this question is that this is also the same distance. It's a radius. So, can you see what you would do first? Well, in the question, you're given this angle here, and you're given this length here, and you know that this is a right angle, and you have to find R. So hopefully you've seen that we have an opposite situation here, and we have a hypotenuse. So if you write SOHCAHTOA here, now for those I teach will know full well that I sincerely do not advise just going straight into SOHCAHTOA without knowing about the unit circle. And if you want to know the bases of how SOHCAHTOA comes about, then just have a look at the playlist entitled Trigonometry, and you'll see some videos in there. So, back to the triangle that we looked at, the right angle triangle. We had the opposite situation, we had the hypotenuse. So in this case we're going to be using this one. So we've got the sine of the angle, which is 35, is opposite in this case, which is r, divided by the hypotenuse, which is 7. So we can simply times both sides by 7 here, and we'll have r equals 7 sine 35. Now at this point you can either decide to put this into your calculator and decimalize, or you can just hold fire for a moment and then just see what develops in the question. Because don't forget, what you're trying to do here is to find this distance here, B to C. So all we've found is this so far. So what I'm going to do is I'm going to double that up to find the whole length of BD. Okay, so I'm just going to say, therefore, that's 3 dots, therefore BD will be twice as much, which will be not 7 sine 35 but 14 sine 35. And for those that are scared about trigonometry, i.e. sines and cosines, then what we can do here is we can just decimalize as well at the same time. So if we do 7 sine 35 here, then your calculator would say just 4.0150355054, and I'm just doubling that. So if we times that by 2, we get here 8.030070109, and so on. Okay, so that's all I've really done. But when you go to higher level maths, beyond GCSE, you tend to leave things in terms of sines and cosines until the very end. So we've got BD. Now, what we want to do is obviously find Y as fast as possible. So what information do we actually have here to help us do that? Well, we have the angle. We now have all of this length here. And we also have this angle here, 90 degrees. So we should be able to find everything we want. So as this is GCSE, I think what I'll do is I'll make this in terms of the decimals that we have already. and we'll go from there. So in this situation, if we look at the right angled triangle BCD, then we have an angle here, and we want to be involving the adjacent this time and the hypotenuse. How do I know that's the hypotenuse? Because there's the right angle, and the hypotenuse is always opposite it. Okay, so I've got adjacent and hypotenuse, so we're looking at cosine here. Okay, so what we'll have is cosine of 70 is equal to adjacent, which is what I want, y, over the hypotenuse. Now, you can either call this 14 sine 35 or the decimal, which you may just prefer. But what you don't do is, so if I write this, what you don't do is call this 8.03, i.e. round it and then use it again. You must write down and put into the calculator the whole number as shown. Because for those that may or may not know, 14 sine 35 is exact, whereas its decimal equivalent is not exact. That's only rounded to this case 1, 2, 3, 4, 5, 6, 7, 8, 9. It's only accurate to 9 decimal places. But anyway, for the GCSE and this level of maths that we want, it is definitely high, let's have a look what we can do with y. So in this case, to get y, we would have to, and I'm not going to put equals here, I shouldn't have really done that because it's an approximation. We're going to times both sides by that decimal, 8.0300700109. So our answer should be 8.03 and so on times cos 70. And what we can do is we can just type that straight in. Some of you may already have the decimal 8.0300 and so on in your calculator already, and that's good because you haven't got to type it all in again. And just press times cos 70, and then you should have the answer for y. And I'm going to write down my calculator display. And then I'm going to look carefully at what it wants me to write the answer to. And it says here 3 significant figures. And that's exactly what I'm going to look at now. So let's have a look. The first significant figure, the second, the third. And then we look at this number after. And if it's a 5, 6, 7, 8 or 9, it will make this 4 increase. If it was a 4, 3, 2, 1 or 0, it would stay the same. So in this case, we'd have 2.75 to 3 significant figures. And that would be the final answer for that question.